Chapters 6 and 7 are pretty key. Chapter 6 is focusing on normal probability distributions or the normal curve. And then Chapter 7 is kind of short. It focuses on the central limit theorem. So I'll include both these into this short little review or overview of both Chapter 6 and 7. Chapter 6 is key because so many of the data sets we work with are normally distributed, or we go ahead and make the assumption that they're normally distributed. Chapter 5 was dealing with non-normal distributions, and there is a whole field of literature and study out there that's referred to as non-parametric statistics that specifically deals with non-normal distributions and specific tests designed to deal with non-normal distributions. But this chapter, Chapter 6, is focusing on sort of the major part of modern statistical analysis, at least at an introductory level, which is the normal curve or normal distributions, sometimes also referred to as the Gaussian normal curve, after Carl Friedrich Gauss, who was a primary developer of the normal distribution. The properties of normal distributions are important, so be sure and read through those. A normal curve must be symmetric and bell-shaped, which means the median is equal to the mode is equal to the mean of the data set. 50% are going to lie above the median and mode, 50% of the data lie below. It has a completely defined mean and standard deviation. For the normal curve, the mean is always going to be 0, and the standard deviation is always going to be 1. And in fact, if you look in the front cover of the textbook, there's the standard normal curve and the standard normal table, which is equivalent to what you have on your scientific calculator, which you can calculate either way through the table or the calculator. Back to the normal curve probabilities. Number 3 is that the curve must encompass all of the data sets, so 100% of the data must lie within the curve. X is also a horizontal asymptote, so the tails of the curve approach the x-axis but never reach the x-axis. And that's summarized for you there on the top of 320. Our standard normal curve, which is what we're dealing with, as I said, has a mean mu of 0 and a standard deviation of 1, which is important. And the inflection points, kind of interesting to note, on 318 are always located at plus and minus 1 standard deviation above and below the mean, is where the inflection points are going to be found. Now, what we can do then with a normal curve, if you start off with a normal distribution, is that we can find the probability of any values that lie above or below any other values. And we use both the, as I said, the calculator, the TI-83 or 84, or the front insert in the textbook to find those probabilities. So they walk you through some of the discussion there on how to find those. I primarily learned, maybe it's just being in college 20 years ago, through tables, but the calculator works fine as well if you want to calculate that way. You probably should be able to calculate both ways. If you're calculating by hand, which you can also do this and it works just fine, using normal distribution, then the normal z is always x minus mu divided by sigma, x being the value we're trying to find, mu being, in x terms, whatever the mean is for the data set. And then if we put it over into the z values, that's when we always then get mu is 0 and standard deviation is always 1. So what we do when we're finding the normal distribution is we're normalizing, in a sense, the data because we know it's a normal distribution. Okay, so 6.2, as I said, primarily walks you through using the calculator approach. Should be pretty easy. And then 6.3 introduces you to the equation, moving from x's to z's, and then using either the calculator or the front insert, either way, to find the probabilities above or below or in between certain values. If you have any specific questions, please do let me know. You also, of course, can move from z's back to x's with a simple formula that's there on 354. Your z times your standard deviation mu, z times sigma plus mu must equal your x value. So you can move back and forth between those. And then 6.5 gets into a general approximation of the normal distribution using binomial distributions, which shouldn't be too bad. The key there, though, be sure to remember, if you're entering on your calculator or by hand, you have to do that continuity correction of either x minus 0.5 or x plus 0.5 on both sides to make sure that we've corrected appropriately. And then the normal distribution approximation of binomials is listed there on page 363. But chapter 6 is an incredibly important chapter. You need to go through it and feel pretty comfortable with working, and especially using the calculator. Now chapter 7 gets us into the central limit theorem, which is one of the most important theorems in all of statistics. It basically says that if you have a normal distribution and your data sets are greater than 30, then the data set approaches the normal distribution. So the mean of a sampling distribution, whatever it may be, mu x bar, becomes the mean of the population, mu, as the data set gets larger and larger and larger. Sigma x bar is going to be known as the sampling distribution of the means. And if we have the sampling distributions of the sample means, then our mu changes, our sigma changes from sigma to sigma divided by the square root of n. So there's that adjustment that takes place. And then your graph, as we go larger and larger data sets above 30, are going to look more and more like the normal curve. But there's a good few pages there to describe the central limit theorem. And it is important as we go through. So the calculations we use in chapter 6 are going to differ slightly from the calculations we use to solve in chapter 7, because in chapter 7 now we're using mu x bar, which is the same as mu, so there's no change there, but we're using sigma x bar in our equation, which is slightly different than sigma. Sigma x bar is sigma divided by the square root of n. And they show you that formula there on 396. So instead of x minus mu over sigma, for the formula for the z in chapter 6, now we have x bar minus mu x bar divided by sigma x bar, which is x bar minus mu divided by sigma over the square root of n. And then there is a final section there in chapter 7 talking about the central limit theorem when we're dealing with proportions. And it also has a slightly different equation than we've used before. Now we have mu sub p hat, which is just p, but now you have sigma p hat, which is the square root of p times q divided by n. And they do a pretty good job there in showing you the differences between the chapter 6 problems and the chapter 7 problems. Okay, so that's just a very brief overview of chapter 6 and 7. They are two very important chapters. I encourage you to use the calculator and get comfortable with the calculator and working these problems. You need to obviously be able to do these by hand, but on quizzes or exams, it oftentimes does help if you can use the calculator to work things a little bit quicker.